So after you put zeros and poles on the S-plane, step number 2 is you locate the sections of the real axis uh, where the root locus is present. That is the collection of roots are present on the real axis only. So for step number 2, we are just dealing with the real axis on the left hand side. So how do we figure out where the collection of roots or root locus is present on the real axis? It's pretty straightforward. You look at zeros and poles on the left plane, of course, because our system is a stable system right now. So look at the zeros and poles, and if you have odd number of zeros plus poles, so add both of them together, odd number of zeros plus pole towards your right, then that section of real axis is part of the root locus. And if you have even number of zeros plus poles towards your right, then that section is not part of the root locus. So give you an example. If your 1 plus if your QS is 1 plus K 2S plus 4 over S plus 4 or 2K S plus 2, so if this is your 1 plus GHS or whatever we are calling it, KPS, whatever. So PS here is what? 2S plus 2 S plus 4. So you have poles at S is equal to 0 and S is equal to negative 4, and you have 0 at S is equal to negative 2. So if I go ahead and put those on the S plane, so this is my pole, S is equal to 0. This is my 0, S is equal to negative 2. Don't worry about this. This is my 0, S is equal to negative 2. And this is my other pole, S is equal to negative 4. So if I want to know which section of real axis here is part of the root locus, I'm going to stand here, let's say, and look towards my right. I have only one pole, that is odd number. So this whole section until you hit the next 0 or next pole is part of the root locus. And remember, it starts at root, ends at 0. So as K is increasing, it's going to start from one of the sections, will start from this root and ends at this 0, this pole, and ends at this 0. Okay, if I go in this section of real axis towards my right, I have 1 0 and I have one pole, that is even number 2. That means this section is not part of the root locus. Let's go towards left of the third root, negative 4, and look towards your right. You have one pole, 1 0 and one pole, that is you have 3 zeros plus pole towards your right. That means this section all the way to infinity is part of root locus. There is a 0 sitting at infinity, and this section of root locus is going towards that 0 as the value of K is increasing. So this is how you will figure out that which sections of the real axis are part of root locus. Let's discuss this as well. This is useful actually. Magnitude of K for given S. So you have 2K S plus 2 over S plus P1, whatever the P1 is. Alright, 4, sorry, not P1. Why did I say P1? Looks like P1, but it is 4. It is the same function as we have over here. So, and of course this is equal to negative 1. As we know, 1 plus Fs is equal to 0, or 1 plus KGS equals to 0. So this is in KGS or KPS, whatever you want to call it, equals to negative 1, and K will be equal to negative half S square plus 4S over S plus 2. You take it over there on the other side. Now remember, magnitude of K is equal to the magnitude of this, where S is a complex number. So 1 over half, and the magnitude of the numerator divided by magnitude of numerator. So let's assume any point on the root locus you take. Let's say s is equal to negative 0.5. Where is s is equal to negative 0.5? Somewhere over here. So let's say you say, okay, I have one of the points on the root locus is negative 0.5. I want to know what the value of k is for that. Very simple. You take s is equal to negative 0.5, go ahead and plug this in over here, take the magnitude, that's going to be the value of k. As simple as that. So it is a very easy method to figure out what is the value of k for any corresponding point on the root locus. This is something that I discussed, separate loci. Number of separate loci is equal to number of poles, since number of poles are greater than or equal to 0. So remember, your root locus will always start at pole and go towards 0. So whatever number of poles you have, you will have that many sections of root locus, because one collection of roots will start at one of the poles and go towards 0. Now 0 can be either finite or it can be infinite, that is sitting at infinity. But there will be the number of sections of the root locus is always equal to how many poles are there, and those are the separate loci. Another characteristic of root locus is complex roots. If you have any complex root, whether you have poles or zeros, and since complex roots always come in complex conjugate, so the root locus is always symmetric. If you do have complex root locus is always symmetric with respect to horizontal axis, and that you can see in this example as well. Observe that it is horizontal, it is symmetric with respect to horizontal axis. And see how many sections of root locus are here. There's one section blue, one section whatever the light yellow color, one section dark yellow color or kind of orangish color, and the last section is the blue color. And we have 4 poles, 1, 2, and there is a double pole over here. So number of separate root loci section is equal to number of poles.